All right, how we doing, everybody? Hope you are having a great day. Hopefully that is all recording. Uh, you got a sub? Treat the sub nicely. Do your work. Don't be too loud. Thank you. Let's jump into this. We're doing our chapter 2 test review here. Okay, the first thing that you are doing is writing conjectures based on patterns. Make sure that you draw the next pattern in the series. Uh, let's see what's going on here. We're adding another row of dots each time, right? So we could just do. Mine's gonna look worse than yours. So you could say something like, well, moving. Jeez Louise. You say something like adding a new row of dots each time. Okay, so as we go through these, let's make sure that we are writing down these answers, thinking about them. If you want to maybe try them ahead of time and then look back at what I said as the answer, uh, let's say diagonally here. But you should be putting this information somewhere in your notes and following along, okay? So that's that one. This one looks like we add a triangle to the top and the bottom each time. They do change orientation. You might want to try to say that. Okay, but something like add a new triangle to the top and bottom of each previous figure, right? So you're just making a conjecture on what you see is happening, doing the next one in the series. Okay. They do change orientation if you want to mention that because you put one on top. And then the next one would go here, right? Or here, I guess. And then one on top. So you could say something about changing orientation. Remember, the first half of this review is stuff you did on the quiz. If you haven't come and picked up your quiz, come in on Monday or not Monday. We don't have school Monday. Come in on Tuesday and pick up your quiz. Let's do C because you know C is going to be the one that's on the test. Okay. Sorry, my lines are so bad. Short, big, small. So we're going to want to do PQR. Now, most of us got this on the quiz, but some of us did some extra stuff or did some weird stuff. PQR is good. We want to do not P because that's the problem. Okay. Not P is in the problem. There's no not Q. There's no not R. So we don't need to do any of those. So we're just going to do not P. And then we're going to do what's in the parentheses, which is not P or Q. Okay. And then our last one is just the whole thing, which is not P or Q in the parentheses. And then and R. Okay. Remember the V is an or. This guy is an or. And the caret over here is an and. What am I doing? Okay. So well, we're not even done with the setup, right? Now we're going to go and we're going to go 4 trues, 4 falses for P, right? Remember how we do this? And then for Q, we're going to alternate between 2 trues and 2 falses. Two trues and two falses. And then lastly, we got to do alternate every time. So we're going to go true, false, true, false. And that will give us every combination of true and false for the truth table, right? We go from all true to all falses and everything in between. That's why we do it like that. Okay, that's your setup. Okay, now we're going to go through each column, mix it up. So for not P, we're just going to take our P and flip it. Okay, so we're going to go falses, four falses now, right? Because we started with four trues, so we got to flip that, and then we go four trues. All right. Okay, now what are we looking for with an or? Dom, what are you thinking? If anywhere there's one true, it's true. So the only place it's false is where they're both false. Okay. And our first one is not P or Q. So we're here and here. Okay. So the only place that you're going to get a false is where they're both false. So here's an example of that. Here's right below it's the other one. And then that's going to be it. Everywhere else it's going to be true, right? Because we have at least one true. We got four trues here. These two are false, but these are true. Okay, so we should have true, true, and then we're going to get our falses in a row. And then it's going to be true, 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 true. Okay, we need a new color. Last column, we're doing our previous column with R. Okay, our previous column with R. Now it's an and. We need two trues to be true. So it's only going to be true where there's two trues. Okay, well, we got one off the bat. Starting with the true. What a good sign. What a good sign. And we get a false. And we get a false. Right? False, false. Okay, and now we come up on our next true. You can see it here. Here's a true. Here's a true. So that gives us a true. We're going to have one more, I think. False. So that, oh, I shouldn't have circled that one. Can I undo? Yeah. Gosh, I'm smart. Okay. So that's still false because we had one false over here. Sorry, I got a little excited, got ahead of myself. Here's our last true. And then lastly, we end with a false. So it should look something like that for your truth table. I think we pretty much got these down, hopefully at this point. We've done this a lot. Let's see, which one of these are good? You had something like this before. Huh. Okay, we're gonna do one of these. Just don't know which one's good here. It's a good example. I guess let's do this B one. I think we've seen something very similar. I'm gonna type it. Hope that's all right. So the original conditional is if two angles are congruent, then they are vertical angles. Okay, and the truth value on that, Jameson, what do you got? Yeah, it's true. No, I'm sorry. Wait, say it again. No, it's false. No, you have other options. Is this the one you guys did on your? No, you did something different on your quiz. Sorry, I got that wrong. Jameson said false. I just misheard him. Okay. So if two angles are congruent, then they are vertical angles. False. Okay, we could have two congruent angles. And again, your counter example, we got to give a counter example. Your counter example could be drawing something. Could have a little 30-degree angle here, a little 30-degree angle here. These are congruent, but they are not vertical. So that passes as a good counter example. Okay. Let's jump back in. Converse, we flip the hypothesis and the conclusion. If we keep our subject the same, right? We keep our subject the same. If two angles are vertical angles, then they are congruent. What was that? Now, redemption for me, because I messed up on the last one, truth value is true. I just got a little ahead of myself. Two angles are vertical angles, then they are congruent. We know that. That's a theorem. We've learned that theorem. We've done that theorem. Vertical angles are congruent. The inverse, okay? We take the original conditional and we negate it. If two angles are not congruent, then sorry, scroll down. Let's scroll down. Then they are not, sorry, vertical. This would also be true, right? Because we know vertical angles have to be congruent. We know two angles aren't congruent, then they can't be vertical, okay? Lastly, the contrapositive, everybody's favorite, okay? I ran contra. Ask Mr. Hecko about that. All right. If two angles, so again, we negate and flip. We negate and flip the original. So if two angles are not vertical angles, then they are not congruent. Okay, if two angles are not vertical, then they are not congruent. And this is false, right? Similar to the example we gave earlier, we could draw a little picture and yeah, do another counterexample like that. Okay? We got this stuff down at this point. I think we did pretty well overall on that on the quiz. Just be a little careful of your truth values. Basically, everybody got the conditional, the converse, the inverse, and the contrapositive correct. They wrote it out correctly. Just we got a little stuck on some of the truth values. Remember, our original conditional and the contrapositive will always have the same truth value. And same with the converse and the inverse. They'll always have the same truth value. There's more examples here if you want to practice. Feel free to. And that's kind of a review of the quiz. Okay, so that was the quiz. Now we're going to jump in here and we're going to do proofs. So we're going to get some proof practice in. All righty, Rue. Here we go. What a straight line. That is oh, cursed myself there. Okay, so we got statements and reasons. Sorry, I'm not going to write it all out because it's a little tough on the old mouse pad here. Okay, so we're going to do that. We're going to do this. Okay, we're going to write our given. You guys know what you're doing at this point. We're trying to prove x equals 12. If you don't get 12, you made a mistake. That's nice about these, okay? Maybe it's a little annoying to write out every step, but you kind of know if you got it right or wrong. So we're going to go distributive properties. Start us off nice and strong. Distribute that -4 to both, please. So we get -4 plus 12 plus 5x equals 24. What do we want to do next? Leo, what do you think? Yep. Combine like terms? Sure. So we're going to add -4x and 5, and we're going to get 1x plus 12 equals 24. There's two things we could call that, right? Leo said combine like terms. I would accept that on the test as an answer, so that would be fine. What's another way? Alexandra, what do you got? Yeah, we could just call that addition, right? We took -4 and we added 5x. It's not the addition property of equality, but it's just addition because we're just doing it to one side. All right? So there's addition. What's next, kids? Someone said subtract 12. Yeah. Who was that? Lucas back there. We're going to subtract 12 from both sides and we're going to get 1x equals 12. And what's your reasoning? Yes, we're going to do the old subtraction property. What is it? Of equality. Okay, so this one you got to add equality because we subtracted 12 from both sides. We didn't have to divide on this one because we got 1x. Maybe that one was too easy for you all. And then Alexandra's favorite part, make the box. Make the box. Your proof is done. Beautiful. Okay, those should be free points on the quiz. You guys know how to do algebra. You just got to use some terminology. Should be able to get that. All right, segment proof. Let's change colors. Gosh, that line is straight, and then it won't let you do it on the down one. Okay, so we got AC is congruent to BD. That is our given. That's all we get. Jeez, we got some work to do. Now, I'm thinking segment addition postulate is going to come into this. Just hazarding a guess, kids. So let's do AC is equal to BD because we're going to want to get this equal because we're going to do some substitution. Okay. So we're going to set these equal. And remember, that's definition of congruent angles. No, what was it? Sorry, I messed up. Definition of congruent. Someone said it, segments. All right, that gives us the back and forth. Good old back and forth. Okay. What's next? I need a little water. It's a lot of work. Segment addition postulate. Now you want to do the segment addition postulate, okay? Kira, tell us what's up. Kira's got it. Kira's got it. Okay, AC equals, what are the parts of AC? Yep, AB and BC. So we're going to say AC equals AB plus BC. And yep, that's the segment addition postulate, most important postulate you've ever learned. And I know I write these kind of short, but you can too. Sega diff posh, right? That's it. Okay, why did we pick AC? Good question. Look at our given. We have AC right here. That's why we picked AC. Okay. We are given AC and we're given BD. So we also want to do it to BD, right? Use the segment addition postulate with things you're given, AC, BD, or that you're proving. Okay. BD is BC plus CD. And it's the same reason. You can go ahead and use a little quote mark there to say same as above. Okay, and now we said these guys were equal. Okay, we said these guys were equal right off the bat. So since they're equal, we can set them equal to each other. Crazy, I know, crazy. So we're going to say AB plus BC equals BC plus CD. Okay, and that was substitution. Also, if you said transitive property, I would take that. Okay. So substitution there. And then now, what do we see on both sides? Kian, what do you got? We got a BC on both sides? Yeah. So what can we do? Yeah, we're going to subtract it. So we're going to subtract the BC. They cancel each other. They go away. You get AB equals CD. Oh, interesting. That's what we wanted. Good work. And that was subtraction. Property of equality. Last step. Eleanor, you got it. Yep. I don't know why I'm changing colors. Let's keep the same color. Got to put it in congruency. Eleanor's right. Put it in congruency. And that is definition of congruent segments. You know, don't do this on your proof. My hand is already hurting from writing. It's the same thing we did up here, okay? We just go back. You guys know. You write it in. You write it in. Two more proofs. Mr. T can do this. Here we go. We got it. Again, feel free to try these on your own. And then if you get stuck, you can watch it or however you want to do it. I know I've done this before and I run out of room. So I'm going to just try to do it below it. And we might have to glance back up at what's going on. All right. So we got ABC as a right angle. This one's kind of involved. Should we try and type this? My hand is going to hurt. I know it's going to be a lot. I'm going to try and type this. We're going to say angle ABC is a right angle. Okay, that's our given. So what does that mean? We want to remember if we are given words, we want to turn them into equations. Okay, so we got words, we want to turn that into an equation. I don't have a little angle symbol, so I'm just writing it out. So we're going to say angle ABC equals 90. We turned words into an equation. Okay, and for a reason, we could just say, I don't know why I'm just not. For a reason, we could just say definition of a right angle. All right, what are we trying to prove here? So we got the given, we did that. Let's look at back at this thing. I'm trying to prove ABD, which is this smaller angle here, and CBD, which is this smaller angle here, are complementary. Okay, we probably already know that this is true, but let's do it. Prove it. We're proving it. And we know that this is 90. What else is ABC equal to? What else is ABC equal to? It's equal to its smaller parts, right? So we're going to say angle ABC, angle ABC is equal to angle. We're going to do the first one, ABD. Sorry, we went over a little bit. How can I move this? Maybe I do that. Okay, it's a little better. Slightly better. Angle ABD plus, okay, the other smaller one is CBD. Okay, so angle CBD. What do we call this? Yeah, it's the angle addition postulate. We saw the segment addition postulate earlier, but this is the angle addition postulate. Okay, cool. So now we got that. Look at what we have here. Okay, we got angle ABC here. We got angle ABC here. Maybe we could set those equal. Let's do that. If we go ahead with that, okay, we get angle ABD plus angle CBD. Whoa, they're cutting us out here. What is that equal to? It's equal to 90 because that's what ABC was equal to up here. Okay, so we got these two are 90. Okay, call that substitution. Yeah, geez, we got there. Substitution. Okay, and now we always got to end with the proof statement. Okay, even though we can see that they're complementary here, we got to end with what it says to prove. So that's our last thing is just say that they're complementary. Okay, so last line, angle ABD and angle CBD are complementary. Okay, and then over here, just definition of complementary angles. Okay, now this one you have done before. It is in your notes. So I would suggest, it's been a while since we've seen it. I would suggest you try this on your own. And then you go into your notes, you find out, it's one of the first proofs we did. Go into your notes, find out if you did it right, see how you did, compare now to then, and see how you did. You do want to try to do some of these on your own. So see if you can do this one on your own. Then go back in your notes and you will see that you have done this. Okay? I think that was a lot. I think that was like 25 minutes. So I'm going to sign off. Hopefully that gets you somewhere, gets you going. There's other problems in that packet you can do and finish. So do those. And then you got another small little assignment in the book, just a couple more problems here and there to practice. If you have questions, feel free to send me an email. And I hope you have a great weekend. We'll talk to you later.